all your data belongs to us. I'm at libevm on the Twitters. Yeah, Google Gaga Gum Gum, Google libevm on Twitter. Currently, I work at Mantle, and on the side, I work at Cryptic Woods, where we have an MEV dashboard. And in the process of making the MEV dashboard, libmev.com, I've run into a couple challenges and issues regarding the data processing pipeline. And I thought I would just share my struggles with you guys today on how to better extract, transform, and load your data. So the focus of this talk today would be loading part for now and just be focusing on the extraction and the transformation of things. The goal of this is to create an application where data extraction is highly optimized for pre-processing and all post-processing, including any kinds like libmev.com. We are a MEV dashboard where we do a lot of bespoken transformations for transactions. For example, how much ETH did this bundle extract, so and so on. So there's a lot of accounting, a lot of data that you have to account for. And I'll be going through what I use on the back end to achieve these kinds of transformations. We have a couple goals with the transformation side of things. We want to make it easy, we want to make it backfillable, and we want to make it fast. By easy, I mean that you don't need a PhD in computer science plus 5,000 at any arbitrary point in time. And this is easily achievable with an archival node. And we also want it to be fast. So yes, we'll be focusing on the extract side of the pipeline for the time being, packaged as a binary to extract blockchain data into a variety of formats. There's Parquet, there's CSV, there's JSON, your analysis. It's just like a pandas data frame for any one of you guys who's done any sort of data analysis, Python. And this brings up a lot of possibilities because the main backend of Cryo is written in Rust. So if it's a float, if it's an unsigned integer of 8 bytes of 16 bytes, or is it just an integer of 8 bytes, I want to perform some analysis on it. So, and also Cryo also extracts data in parallel or asynchronously by default. So a lot of the bottlenecks that you get with Python, you can easily overcome it with Cryo. There's a couple data sets in Cryo where you can play around with. There's balances, there's blocks where you get the data such as the block number, the hex string, the block value, the minor, and so on. Like you can also query ERC20 balances, such as like how many USDC was in this contract at this given time, or how many USDT was in it. I'm focusing on the ETH calls in particular because this allows you to create bespoken data sets. When I say bespoken data sets, I mean data sets that are not specific to the chain, but rather are stored in arbitrary state. For example, the price of ETH against USDC on a Uniswap V2 pool, for example. And for those of you who are not familiar with ETH call, how it works behind the scenes is that if you would like to query custom data back, so if you go to uniswap.org or any other exchange and you put in 1 ETH to USDC, generally what happens is that it would perform an ETH call to the blockchain to query how much USDC you might get out. And that's the whole point of ETH call, is to query data from the blockchain. And we can now use ETH call inside of Cryo it's very simple. You import the Cryo package in Python and you call .collect and you provide it with ETH calls. In this specific and USDC. And I'm querying it for the latest blocks and the 5 previous blocks. So I would like to, so this is the code, getting the reserves. And if I run this file, this is main.py, I should be getting 5 blocks of data of the Ethereum price. So Python, hopefully it works. Hopefully the latency isn't too bad here. Cool. So the price of Ethereum right now is 3,037 USDC. I hope everyone can see it. I can zoom in a bit more. 3,037 USDC on block 2119 18, 123, 123 to the latest 10. All right. We can also query the time, but this is how simple it is for you to extract data at any arbitrary point in time using Cryo. All right. So the problem with Cryo is that if you would like an additional data, you now have to query it in a separate call. So for example, if I wanted the price of ETH against USDC on that particular block, I have to do one ETH call. If I would like the price of ETH against WBTC, I would have to do it in a separate call. This is extremely lame if you're trying to build a data set that is very expressive, because that would mean that the amount of queries that you're performing will blow up. One network request for each query isn't great. We have an O of n, and we want an O of 1. Can we achieve that? The answer is yes. Of creating a bunch of separate queries to the blockchain, you would query the multi-call contract which lives on the blockchain, which would then help you query all your queries against that chain in one query. So the very small distinction now is that instead of using Cryo to call that particular contract, you're now using Cryo to call multi-call 3 to call a variety of contracts, all in one query. And if you're a front-end developer trying to save on, trying to reduce the number, optimize your front-end load speed, multi-call 3 is actually a really good tool, because you can now query up to like a variety of information, like an arbitrary length of information in one query, reducing a bunch of variable load speed times into one query. Very handy, highly recommended. The main problem with multi-call 3 is that you now have to encode and decode your data in a more complicated format. You can't just call get reserves. You have to encode your data into a relevant format. You have to first, this is just the decoding bit. Previously, this was all you needed to do. You just call toAddress and get reserves, and you get the numbers out. But now, the output data is the output data from Cryo. You now have to decode it into an array of query within multi-call 3 to get your data out. Oh, I messed up the side too. It was this one. UniV2 WEF USDC. We have to encode it to be multi-call 3 compatible, aka a array of address and bytes and a bool. The bool basically just means do not stop if it fails, and only then can we encode it for multi-call 3 and perform the necessary code 2. All right, so this is our initial file. Let me zoom out a bit so I have some space. Let's go to the multi-call 3 file. Notice how much more, it's slightly more. Previously, we could just directly call get reserves to the UniV2 pool, but now, and if we run the multi-call 3 file, it should produce us a similar results. M3 main. All right, so this is the current ETH price. But let's say I would like to get another call data, maybe a different pool, a different UniV2 pool. What I can do now, ETHScan, UniV2. We'll try to get the price of BTC against USDC. Oop, oop. God damn it. UniV2, copy and paste this, WBTC, USDC. So this would encode the data into it, but we haven't decoded it. So we still only have the Ethereum price against USDC here. What we need to do now is copy paste this function, change the return data from 0 to 1 because it's now the second query. And if I remember correctly, WEF is always bigger than BTC, I think, depending on the address. Address 0x22, yep, so it's WBTC reserve and USDC reserve. And we'll just copy, paste. WBTC is 18 decimals, USDC is 6 decimals, so this is WBTC USDC. Hopefully this is right. Okay, great, it worked. So we got the price of Bitcoin against USDC on all these blocks. And this is all done within one query per block. Very handy. And in fact, you can change it to some arbitrary point in time. For example, if you want it on block 17 million, Ethereum on block 17 million, and the price of Bitcoin at block 17 million, all done in one query per block TM. Yeah. So yeah, that's it. That's my live coding. I really appreciate you guys hearing me ramble. That's my Twitter at libevm. If you guys want to check out the examples for the code above, you can check out my repository at github.com/libevm/Cryo-Python-example. Happy to take any questions if there are any. No questions? Great. Everyone is speechless. Thank you for your time, and I appreciate it.